Hello guys. So today we are going to explore the world of HCF and LCM, which you may have got the idea from the title of the video. So basically I was solving a sum on HCF and LCM, and one day it occurred to me that I don't know the proof behind this equation, which is HCF into LCM is equal to product of two numbers. So I actually explored and found it. So I wanted to share with you all the proofs. So the proof goes as follows. We take two numbers n1 and n2, and here k is the HCF of them. HCF, highest common factor. So common factor means that the HCF divides both the numbers. So k into something, n1 is equal to k into something, let it be q, and n2 is equal to k into something, let it be t. So if q, we assume that, let's assume that q and t have a common factor. For example, 2 and 4 have a common factor as 2. So let's us assume that q and t have a common factor. Let it be n. So the n divides both q and t. So let q be n into something. Let it be p, and let t be n into something. Let it be s. So now we see that HCF of the two numbers becomes kn, because kn divides both the numbers. Thus, the HCF should not change because it is the highest common factor. Therefore, n has to be 1. Therefore, there does not exist any common factor. There exists a common factor which is 1. So, Q and T are co-prime. And LCM is the common multiple. So, LCM is equal to KQ into something. Common multiple means, for example, 13 and 26 are the numbers. So 13 into 2 is equal to 26. 26 into 1 is equal to 26. This is the LCM of them. So we are multiplying the number by something to get the LCM. So let it be alpha. N1 into alpha is equal to LCM. N2 into beta is equal to LCM. So we get that Q into alpha is equal to T into beta. Now we also know that Q divides beta, because Q does not divide T as they have no common factors. So beta is equal to Q into omega 1. Similarly, T divides alpha because it cannot divide Q as T and Q are co-prime. So alpha is equal to T into omega 2. So Q T omega 2 is equal to T Q omega 1. So we get that omega 2 is equal to omega 1. And we also know that we have to minimize the multiple because it is known as the least common multiple. So we let omega 2 is equal to omega 1 is equal to 1. So we get that LCM is equal to KQT because beta is equal to Q. So LCM is equal to KT into Q. So LCM is equal to KQT. And we know that HCF is equal to K. So HCF is into LCM is equal to K into KQT is equal to KQ into KT. And we know that KQ is the number right here, N1, and KT is the N2 number. So we get that HCF is equal into LCM is equal to product of two numbers. So I didn't stop here and explored further. So it was my curiosity which led me to explore further that why only this HCF and LCM is valid for only two numbers. So I was curious about this thing. So I am going to share that why it is only valid for two numbers, and also I have derived a formula for a special case of it. So yeah, why there is no formula for HCF and LCM for n numbers for n greater than 3. So if there are three numbers, so HCF into LCM is equal to something like that. So we assume that n1 is equal to k alpha 1, n2 is equal to k alpha 2, n3 is equal to k alpha 3. So n. So there are n numbers, k alpha n. So these have a common factor, HCF, which is k. Any two of these numbers, if we assume that any two of these numbers have a common factor. So for example, there are three numbers. So for example, there are three numbers, 2, 3, 4. So we notice that any two of these numbers. So yes, 2 and 4 have a common factor which is equal to 2. Highest common factor equal to 2. Then the HCF would not change. So meaning is that although these two have a common factor, but in general, these three numbers do not have a common factor, meaning that 2 does not divide 3. So we notice that these two have a common factor 2 and 4, which is 2, but 3 has not a common factor. So the HCF would remain the same, which is 1. 2, 3, 4 have a common factor, which is 1. But if alpha 1, alpha 2, alpha 3, meaning that all are co-prime. So for example, for this is 13, 26 and 39. So 13 into 1 is 13, 13 into 2 is 26, 13 into 3 is 39. 13 is the highest common factor. And we notice that 1, 2, 3 are co-prime and have a common factor 1. So in this case, we let the LCM using the same process. The n1 into something is equal to LCM, n2 into something is equal to LCM. So we let that be b1, b2, bn. So using the same process, we get that alpha 1 b2 is equal to alpha 2 b2 is equal to alpha n bn. So we notice that alpha 1 divides bn because alpha 1 does not divide alpha n because they are co-prime. Alpha 2 divides bn. So we get that alpha. So alpha 1, alpha 2 and alpha n minus 1 all divide bn. So bn is equal to alpha 1, alpha 2, alpha n minus 1 because we have to minimize to get the least common multiple. So we get that alpha n into bn is equal to alpha 1. Bn is equal to alpha 1, alpha 2, alpha n minus 1 omega. And we have to minimize. So we get omega is equal to 1. So bn is equal to alpha 1, alpha 2, alpha n minus 1. So the LCM becomes k alpha n into this thing. So we get that LCM is equal to k into product of all the co-prime numbers. LCM is equal to k alpha 1 dot 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 alpha n. So the product of n numbers is k raised to n alpha 1 alpha 2 n. So if we divide product of numbers, so you notice that product of numbers is equal to k alpha 1 into alpha 2 into alpha n into k raised to n minus 1. So we get that product of n numbers is equal to LCM into HCF raised to n minus 1. HCF is k is equal to product of n numbers when alpha 1, alpha 2. So this formula is only valid when alpha 1, alpha 2 and dot 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 alpha n are co-prime. So thank you for watching the video. Please hit the subscribe button.